Hi there, and welcome to this lesson on Pure Mathematics 1. And in this lesson, we're looking at perpendicular lines. Two lines are perpendicular if they're at right angles to each other. So, for example, these two lines, line 1 and line 2, they're at right angles to each other, they're perpendicular to each other. By choosing 2 points on line 1, we can calculate the gradient of line 1. So, for example, we could choose those 2 points. And I've called the horizontal distance here A, the vertical distance B. The gradient's equal to the change in y over the change in x. So the gradient of line 1 will just be B divided by A. Now we can then do the same thing for line 2. Because they're at right angles to each other, when we create this second triangle, it is possible to create two congruent triangles. So that this triangle for working out the gradient of line 2 is congruent to this triangle for working out the gradient of line 1, where the vertical distance will now be A and the horizontal distance will now be B. Working out the gradient of line 2, the vertical distance, as we said, is A, but you are going down, so it'll be minus A divided by B. So the gradient of line 2 would be M2 equals minus A divided by B. So those are the two gradients of the perpendicular lines. One of them is B over A, the other is minus A over B. Now there are two ways that we can choose to write down the way these two gradients relate to each other. The first thing we can do is just multiply the two gradients together, M1 times by M2, which will give us B over A times by minus A over B. The B's cancel, the A's cancel. All you're left with is minus 1. So when two lines are perpendicular, the product of their gradients will always equal minus 1. Also, the other way around, it's true. If you have two lines and you know that the product of their gradients is minus 1, that means those two lines must be at right angles to each other. They must be perpendicular to each other. Now, frequently, rather than using this form, we just rearrange that form to give M2 in terms of M1. And that gives us M2 is equal to minus 1 divided by M1. Now, this form is more useful if you know the gradient of the one line and you're trying to work out the gradient of the other line. So if they're perpendicular to each other, the gradient of the second line will be minus 1 times by the reciprocal of the gradient of the first line. Okay, 3 examples for you to have a go at. A reminder of the 2 rules at the top, and then you've got 3 pairs of lines. In each case, you have to write down whether the lines are parallel to each other, whether they're perpendicular to each other, or whether neither thing is true. My recommendation would be that you try and write all of the equations in the form y equals mx plus c, because then it's very easy to see what the gradients of the two lines are. But I'll let you have a go yourself first. So pause the video, have a go, and then come back to me again when you're ready. Okay, let's have a look at these. So the first question, line A has the equation y equals 3x plus 1. Line B, 4y plus 12x minus 2 equals 0. Now, line A is already written in the form y equals mx plus c. So the gradient of the first line is 3. Rearranging the second line, getting the y's on their own on the left-hand side would give us that. And then dividing through by 4 gives us y equals minus 3x plus a half. The gradient of the first line is plus 3. The gradient of the second line is minus 3. Now, those two gradients are not the same as each other. 3 doesn't equal minus 3. One's uphill, one's downhill. So they're not parallel. And if we multiply those two gradients together, m1 times by m2, we get 3 times minus 3 is minus 9. So the gradients of the lines are not equal. And furthermore, the product of the gradients is equal to minus 9, not minus 1. So those two lines, they're not parallel to each other, nor are they perpendicular to each other. Question 2. Now in question 2, the second line's been written in the form y equals mx plus c. So the gradient of the second line is 5, but it's the first line that we need to rearrange. So keeping the y's on the one side, moving everything else to the other would give us that. And then dividing through by 5 would give us y is equal to minus a fifth x plus 2. So the gradient of the first line is minus a fifth. The gradient of the second line is 5. Now clearly they're not the same gradient as each other, so the two lines are not parallel. But if you multiply the two gradients together, 5 times by minus a fifth, that does give you minus 1. So the two lines must be perpendicular to each other. Okay, the third question. This time, neither line is written in the form y equals mx plus c, so we do need to change both of them. Looking at equation A, first of all we have to do is divide through by 3. Dividing by 3 gives us y equals 4x plus 7 over 3. So the gradient of equation A would be 4. Equation B needs a little bit more work. First of all, keeping the y's on the left and moving everything else to the right would give us that. And then dividing through by 2 gives us y equals 4x plus 1.5, 3 over 2. The gradient of the first line is plus 4. The gradient of the second line is also plus 4. Therefore, since the gradients of the lines are equal, the two lines must be parallel to each other. Okay, a slightly harder example for you to have a go at. Example 2. We have a line and we're told that it's perpendicular to another line, 6x minus 2y minus 14 equals 0. And we're told that the line that we want to know the equation of also goes through the point 6, 11. Find the equation of the line. I recommend that you use y equals mx plus c. Try and find the gradient first, m, and then use the coordinates of one point on the line in order to find out c. But I'll let you have a go yourself. Pause the video, have a go, and then come back again when you are ready. Okay, now to find the gradient of the second line, we need to know the gradient of the first line. And the first line has equation 6x minus 2y minus 14 equals 0. So like on the previous example, we need to rearrange that. Now moving the 2y to the other side and then swapping everything over will give us 2y equals 6x minus 14. Dividing through by 2 will give us y equals 3x minus 7. So the gradient of this line is minus 7. And at this point, I would just write down the equation of the new line will be y equals mx plus c, because that's the equation of every straight line. Then we need to find the gradient m, and we need to find the y-intercept c. Well, we know the gradient of the line that it's perpendicular to, which is 3. So the gradient of the new line will be given by m2 equals minus 1 divided by m1, which is minus 1 divided by the gradient of the line that we know. So minus 1 divided by 3. That's the gradient of the new line. We can now substitute that into y equals mx plus c. And that will give us y equals minus a third x plus c. The method for finding out c is nearly always the same. You use a point that you know on the line. And in this case, we know the point 6, 11 is on the line. So we substitute x equals 6, y equals 11 into the equation. And that will give us 11 is equal to minus a third times by 6 plus c. Minus a third times 6 is minus 2. And then adding 2 to both sides gives us c must equal 13. Now we know the equation of the line we've been asked to find. And the equation will be y equals minus a third x plus 13. Okay, that gets us to the end of this lesson. If you have the textbook, turn to page 95 and have a go at exercise 5F. Thank you very much for listening and cheerio.